Hello everyone. So I wanted to talk a little bit about logarithms and how they affect the interpretation of our coefficients when we have them in our regression. So let's start with a typical example of the linear regression that we've seen in class. So imagine that we want to focus on beta 1. The interpretation is pretty straightforward. On average, for a 1 unit increase in x1, y increases or decreases, depending on the sign of beta 1, units holding x2 constant, okay? So because there's no logarithms, this interpretation will depend on the units that y and x1 is measured. What happens, however, if we have logarithms here? What you should always have in mind is that if we have a variable that is in a logarithm, you should think about that interpretation as a percentage change in that variable, okay? So either if it's y or x, every time that we see something in a log, that means that that variable is going to change in percentage terms. So what do I mean by that? Let's see some examples. So this is a log level regression. What do I mean by log level? This means that our dependent variable is in a logarithm and our covariates are not, okay? And again, we're going to focus on beta 1. So in this case, because y is in a logarithm, then this will change in percentage terms, and x1 is going to change in units. So let's look at the interpretation. So if we wanted to explain what beta 1 is capturing, we would say, on average, for a 1 unit increase in x1, y increases or decreases by e to the power of beta 1 minus 1 times 100%, holding x2 constant. I understand that that is a mouthful, so let's put some numbers into beta 1. So imagine that beta 1 is actually 0.05. What you need to do first, always, is actually calculate this term right here. So we're going to raise e to the power of 0.05 minus 1 times 100, and that actually gives you 5.127. So if I wanted to interpret this now, I would say, on average, for a 1 unit increase in x1, y increases by 5.1%, holding x2 constant, okay? So again, the interpretation is pretty straightforward. The only thing that you need to do is actually calculate this thing. If you don't have like a calculator at hand or something, this actually might be a bit more complicated. So are there approximations that we can use? The answer is yes. If beta is small enough, I would say under 0.1 usually, you can actually just take that coefficient, multiply by 100, and interpret it in the same way. So for instance, if our beta is 0.05 in this case, we can just multiply it by 100, so that would give you a 5% change, and we would interpret it in the same way. On average, for a 1 unit increase in x1, y increases by 5%, holding x2 constant, okay? Let's look at another example, but now our x is actually in a logarithm and y is not, okay? So that's why this is called a level log regression. We do exactly the same thing, but remember, because x is in a logarithm, that is going to change in terms of percentages, okay? So let's see how we interpret this. On average, for a 1% increase in x1, y increases or decreases by beta 1 over 100 units, holding x2 constant. Again, the two key things here is that x1 is in a log, so this will change in percentage terms, and y is not, so this is going to change in units. Okay, let's put a number into this so it's more clear. Imagine that beta 1 is 610, so I would say interpreting beta 1 here as on average, for a 1% increase in x1, y will increase by 6.1 units, holding x2 constant, okay? So again, just divide beta 1 by 100, and remember that x1, it's going to be changing in percentage terms, okay, not units. Finally, let's go to the log-log regression. This basically means that our dependent variable and our covariate are both in logarithms. So again, you can think about this kind of as a elasticity if you've covered that in some econ courses. But again, because this is in a log and this is in a log, both of them will be interpreted as percentage changes. So let's go again to beta 1. On average, for a 1% increase in x1, y will increase or decrease by beta 1%, holding x2 constant. So this is actually pretty straightforward because we don't need to do anything to beta 1. The only thing that we need to remember is to interpret this as percentage changes. Let's put a number into it. So imagine now that you run your regression and beta 1 is 4.3. You would interpret it as, on average, for a 1% increase in x1, y increases by 4.3%, holding x2 constant. Okay? So again, always remember that when we're talking about logarithms, if a variable is in a logarithm, that needs to change in percentage terms. Okay? So look at these formulas, make a little table out of it, and you can just go back into it to know how you need to transform beta 1 in order to make the right interpretation of the association.